Today's video will demonstrate how to identify the level of coupling of a function. Hello, I'm James Helfrich. There are two modularization metrics, cohesion and coupling. Cohesion describes what a single function does, hopefully it does one thing and one thing only. Coupling, on the other hand, describes the information interchange between functions. This video will explain the different levels of coupling and also show you how to identify the level of coupling of a given function. Coupling is the measure of the complexity of the information interchange between units of software. In other words, how much does the programmer need to know to successfully use a given function? Our goal is to make the interface as simple as possible. Remember, the simpler it is, then the easier it is for the client to use it. Now, there are actually 7 levels of coupling. The first is trivial. Trivial means there is no information interchange between functions. In other words, the function returns nothing and takes nothing as a parameter. Then we have encapsulated coupling. Encapsulated coupling means that all the parameters passed between functions are as convenient as possible and are always invalid. In other words, we're passing objects and the objects perform the validation for us. Simple coupling is when it's easy to create the parameter that you want to pass to a function and easy to interpret it. In other words, we can interpret it with a simple assert or if statement. Complex requires much more work to validate the parameters. Oftentimes, we need to have a loop to walk through an array to make sure every element is valid, for an example, in complex coupling. Document coupling is when the information interchange between functions is a complex document having a rich language that needs to be parsed. Interactive coupling involves a dialogue. In other words, the information passes between two functions more than once in order to create a given exchange. And finally, the worst kind of coupling is superfluous. Here we have more information passed between functions than is actually necessary. Now, our goal is to make our coupling as simple as possible. So trivial, encapsulated, and simple are always what we're striving for. Now, sometimes it's not possible. We have to go to complex or document or interactive. And those are going to try to avoid as much as possible. There should almost never be a time where we have superfluous coupling. So let's take a look at simple and encapsulated. Encapsulated is a very weak form of coupling defined by the parameters being in a trusted and accessible state. In other words, there are logical checks in place to ensure that no invalid data is sent between modules. Simple coupling, on the other hand, is when all information exchanged between units of software is easy to select, easy to interpret, and easy to validate. Parameters consisting of built-in data types such as integers and characters and floats are often simple, assuming the parameters are used that are easily specified. So for an example, here is encapsulated. Encapsulated, I want to see if value 1 and value 2 are equal. Now notice there's only 2 possible values for a Boolean, true or false. Therefore, it's never an invalid state and it's super easy to validate. Simple coupling, on the other hand, involves more work. In this case, I need to validate the parameters in their correct state. Now, I'm going to have value 1 and value 2 as Boolean values, but I'm using integers to represent them, which means that I expect the values to be always 0 or 1. Now, if the value is negative 36 or 128, that's not the expected value. So I can easily verify this with an assert. The requirement of an assert is what makes this simple as opposed to encapsulated. Now, superfluous coupling is when there's more information interchange between functions than necessary. Usually this happens because I pass an extra parameter, but it could also happen when the scope is larger than necessary. Now, this is a fairly complete list of different kinds of scopes we can have, with a small scope on the top and the largest scope in the bottom. The smallest scope is a block, which is a small segment within a given function. A local variable is slightly bigger. It's alive for the entire length of the function. A one-way parameter into a function is slightly bigger than that. The parameter goes in, but it does not come out, or goes out, but does not come in. A two-way parameter is when the parameters goes both in and out. Now, a common form of superfluous coupling is when I do a two-way parameter when only one way is necessary. A function static is bigger than that, and this means that the variable is shared with all instances of a given function. A private member is even bigger than that because it's available to all methods within a given class. An inherited member is all members within a given class and all the derived classes. A public member is accessible to all members within a given class, as well as the object itself. Class static is shared between all instances of a given class. A global variable is accessible to every function in the process space. The file system is accessible to not only my program, but other programs. And then finally, protected network and global network. Clearly, we want to make the information available in the smallest possible scope because that makes it easier for us to identify the most important things about a variable: who created it, who looks at it, and who changes it. Okay, so let's take a look at this function here in C++. I want to determine the level of coupling. Now I'm going to take input, which is a string like Schmidt, John, Jacob, Jingleheimer, and I want to turn into an output of the different names, Schmidt, John, and Jacob, Jingleheimer. Now, this is actually document coupling because there is a rich syntax that I'm expecting. I'm expecting to have a word and then a comma and then a space and then another collection of words. If it's in an unexpected order, then I'm going to have a problem. It is difficult to validate this. I have to know the complete syntax of the input string in order to validate the input parameter. That's what makes it document. Now, of course, it's not trivial because there's a parameter, and it's not encapsulated because it's a pointer to a character. It's definitely not simple, and it's definitely not complex because the language is far more rich than that. This is document coupling. Another example, I want to identify the level of coupling in this PHP program. Now, notice, in order for me to connect to the SQL Server, I got to do several things. Number one, connect to the database. Number two, issue the SQL query. Number three, display the results. And finally, I have to close the SQL query. I can't accomplish the connection with the SQL database with just a single call. That makes this interactive. Since there are multiple steps and each step must be done in a certain order, if I do things out of order, things will be broken. That is the very essence of interactive coupling. This is example 13.1 and 13.2 in the coupling chapter of the software design textbook.